Now in the last lecture we have learned how can we insert a string in a trie, and we have created a method in practice. Now in this lecture let's look at how can we search for a string in a trie. So when we are inserting we have 4 cases, but in this case we have 3 cases. String does not exist in trie. So let's say we have a trie like this and we are searching for a string which does not exist in this trie over here. Now the string that we are looking for is BCD, and in our trie we have API over here. So we can easily see that this string does not exist in this trie over here. But how can we check it? Now here the first step is we are going to take the first character of this string and we are going to compare this first character with the root node. So in this case the first character is B and the root node of this trie is A. So we can easily see that B is not equal to A, so this means that this string does not exist over here. So here we don't have to continue to the rest of the characters over here because the first character is not matching with the root node's character. So this means that in this case we can return message saying that the string does not exist in this trie over here. So this is the first case. Now let's continue to the second case. Now in the second case we have a case that the string exists in this trie. So how can we check that if this string exists in this trie or not? So here again the first thing that we are going to do, we are going to take the first character and compare it with the root node. So in this case in our first character we have A, and in the root node we have A. So we can easily see that these two characters are matching with each other. So this means that we can continue to the next node. Now in the next node we have P, and the second character of this string is P. So here we see that these second characters are matching, so this means that we can continue to the next character. So in the next node, which is the child of P over here, we have I, and the third character of this string is also I. So this means that they are also matching, so we can easily identify that these characters over here are matching with the characters of this string over here. But here we cannot say that this string exists in this trie over here, because here we have last step. So in the last step we have to check that if last node's child's end of string property is set to true or not. So in this case we can easily see that I's child is set to the end of string, so this means that API is a complete string in our trie, so this means that API exists in our trie over here. So with this we have successfully learned the logic behind the second case over here. Now let's continue to the third case. So after finding the string over here we can return true. This means that this string exists in this trie over here. Now let's continue to the third case. So in the third case a string is a prefix of another string, but it does not exist in this trie. So how can we identify that if this string is a prefix of another string but it's not a complete string in this trie? So here again we are going to take the first character of this string and compare it with the root node of this trie. So here we can easily see that in the first character we have A, and in trie's root node we have A. So this means that they are matching. We can continue to the next node. Now in the next node, which is the child of A, is P, and the second character of this string is P. So we can easily see that they are matching. So from here we can easily see that AP exists in this trie over here. But here you need to be very careful because you don't need to forget the last step. Now the last step is we need to check that if the P's child's end of string property is set to true or not. So in this case, if we don't have dot over here, it means that it's not set to true. So in this case, after I we have set to child's end of string property to yes, but in this case in I we see that we don't have a property of end of string to true. So this means that AP is a prefix of another string. It's not a complete string. So here we are returning false because in this case AP does not exist in this trie over here. Even though we have AP as a characters, but in this case P's child is not set to the end of string, so this means that AP is a just prefix of another string. It's not a complete string in this trie. So in this case we are returning false. So with this we have learned all 3 cases of the searching for a string in a trie. Now based on this logic over here, let's implement it in practice. Now here, one more time inside trie class, we are going to create search method. So here again, we are going to implement all 3 cases. So let's declare our search method like this. So this method will return the type of boolean, because if we have found the word in a trie, we are going to return true. Otherwise, we are going to return false. So as a parameter, this method will take the type of string word, because we are going to look for a word inside this trie over here. Now here again, the first thing that we are going to do, we are going to create a try node which will keep the value of current node. So in this case, when we are calling this method, the current node will be the root node, so that's why we are setting root node to the current node. So it's going to be like this, try node, so it's going to be the current node, and initially it will be set to root. After setting root, we are going to loop through the word that we are looking for, and in each step we are going to set this current node to the next node. If the character exists in the triad, we are going to continue to the next node, otherwise we are going to return that this string does not exist in the triad. So here we are going to loop through the word, so it's going to as always start from the 0 because index starts from 0. Then we are going to continue until the length of word, and in each step I will be increased by 1. So here the first thing that we are going to do, we are going to take the character from the word, so that's why I'm creating a variable over here which will keep the character that comes from the word. So it's going to be used by character at the index of I. So by using charac at function, we are getting the character which is located at the index of I over here. Now after getting it, we are going to get the value of character from the try over here. So for that I'm going to create a new try node over here. Node will be current nodes dot children dot get with the key of character. So if we have a value for this node over here, it means that this character exists in our try over here. Otherwise, if the node is equal to null, it means that this character does not exist in the try. So in this case, we have to return false, and we have to print out message to the console saying that the string does not exist in this try over here. So that's why if condition will be like this. If node is equal to null, this is the node that we created over here. So in this case, we are going to print out to the console word. So I'm going to concatenate it, the word with the word that comes from the parameter. So here we need to print out saying that does not exist in try. So in this case, it means that the character that comes from this word over here is not matching with the character that we have in the try. So in this case, this is the first case, so in which we said that the string does not exist in the try. So here we are returning this one. Then after printing out this message to the console, we need to return false, because in the first case, the string that we are looking for does not exist in the try. Now let's continue to the next case. Now after writing this if condition, if we have a value in this node over here, so this means that we are going to continue to the next node. So to continue to the next node, we have to set the current node to the node. Then after doing so, after finishing the loop, we have looped through the all characters of the string, and we have seen that all characters are existing in this try over here. But in this case, we cannot return true because we have last step over here. So the last step is we need to check that if the current node's end of string is true, in this case, it means that this try exists over here. Otherwise, it means that this word is a prefix of another complete string, but it does not exist in the try over here. So basically what we are doing over here is, after looping, if we have reached this step over here, it means that all characters exist in the try over here. But last step is, if the end of string is true, we are returning saying that the word exists in this try. Otherwise, it means that the characters exist in the try, but it's not a complete string. It's just a prefix of another string. So that's why I'm going to write if condition like this. If current node dot end of string is equal to true, this means that the word that we are looking for exists in the try. So that's why I'm just going to copy this message from here and paste it over here, and I'm going to change it like this. Instead of does not, I'm going to put exists. Then after doing so, we are going to return true, because in case the string exists in this try over here, we are returning true. Otherwise, in the else condition, we are going to print out to the console saying that this word is a prefix of another word, but it's not exist in our try over here. So I'm going to put like this. The word does not exist in try, but we can print out message saying that, but it's a prefix of another string. So we can easily identify that these characters exist in the try, but they are not a complete string. Now after doing so, we are going to return current nodes dot end of string. Now with this, we have successfully implemented a search method in this trie over here. Basically what we are doing over here is we are looping through the all characters of the word that we are looking for, and we are checking that if these characters exist in this trie or not. If all of them exist in this trie, at the end we are checking the current node's end of string. So if the current node's end of string is true, it means that this word exists in this trie. Otherwise, it does not exist in this trie. It's just prefix of another word in this trie over here. Now let's see how this is working in practice. So inside main class, we have created a new trie and we have inserted 2 strings to this trie over here. Now if I call a search method for this trie, for example, let's call first for API. Now we know that API exists as a complete string in this trie, so this means that it should return true and saying that API exists in this trie over here. So let's run our code. You see that at the end, after the insertion, it says that word API exists in this trie. So let's look at for API-S, because we have inserted API-S also over here. So if I run our code one more time, you'll see that in this case, API-S also exists in this trie over here. So we see that we have inserted API and API-S, but in this case, AP is just prefix of another word over here. So if I run this method for AP, you'll see that it says that AP does not exist in this trie, but it's a prefix of another string. So we can easily see that AP is a prefix of these strings over here. So for example, if I call for APS, we know that APS does not exist in this trie, so it should return saying that APS does not exist in this trie. So in this case, you see that APS does not exist in this trie. So we have successfully implemented all 3 cases inside search method over here. Now let's see what's the time and space complexity for this method over here. Now it's obvious that the time complexity will be OM, because in this case, M is the number of characters in a string. So in this case, we have to loop through the all characters of the word over here. So this loop will take OM time complexity. So the time complexity for whole this method will be OM. But in this case, the space complexity is O1, because in this case, we are just looping through the characters of this word over here, and we are returning message to the console based on the conditions that we have over here. So this means that it's not a space consuming operation, so the space complexity for this operation will be O1. Now with this, we have completed search method in Trie. So hopefully everything is clear about search method in Trie. So in this lecture, we have learned the logic behind the search method, and we have implemented all 3 cases in practice. So hopefully everything is clear about search method in Trie. Now in the next lecture, let's see how can we delete a string from Trie. So see you in the next lecture.